Hello everyone, today we are going to see how to solve a linear differential equation using Laplace and inverse Laplace transform. For this we have to use most important property of Laplace transform, that is derivative property. Then we will find from that derivative y of s. From y of s, applying inverse Laplace transform, we will find f of t, which will be our final solution. We will see the derivative property of Laplace. So what the derivative property of Laplace says that if there is a given function, if any function is given, y dash f of t is given, then we have to find the property after applying on the function. We get s into capital F of s minus small f of 0. For nth derivative, we will apply this property. Like capital nth derivative goes up to s power n f of s till the n minus 1 f of 0. We will understand this using the question. So this is our question. We will step by step find the transform and then we will apply the derivative property. dy or dt. Applying derivative property, we will get capital F of s f of y minus f of 0. Now we will find of 2y. 2y is equal to 2 into capital Y of s. Then we will find integration first, and after integration we will apply derivative property of Laplace. Then we will get integration 0 to t y dt is equal to 1 upon s capital Y of s. For sin t is equal to 1 upon s square plus 1, as coefficient of t a is equal to 1. Now we will further rearrange and find f of s.
To solve this question, we will take the help of this properties. In this question, firstly, the derivative of dy by dt is given as s into y of s minus y of 0. For 2y, 2 can be taken out of the Laplace, and there Laplace of y is plus y of s, and 2 is taken out from Laplace, that is 2 plus firstly we will find the Laplace of y and then integrate use the Laplace of integration. Derivative of y is y of s, and by integration property we divide y of s is divided by s equals to in right hand side we have the Laplace transform of sin t is 1 upon s square plus 1 square, and we can rewrite it as 1 upon s square plus 1. Further solving this, we take off of y of s in one bracket common out, and by putting the value of 0, y of 0, and shifting it to RHS is equal to 1. Here coefficient of y of s is s, plus coefficient of y of s is 2, plus coefficient of y of s is 1 upon s. We will take this in one bracket. Y of s is equal to 1 upon s square plus 1. By shifting this y of 0 to RHS and putting the value of 1, we get this. By solving bracket y of s equal to multiplying this s square plus 1 to 1, that is 1. By solving this, we can write it as s square plus 2 upon s square plus 1. After solve this question, we have to take this term to RHS. By shifting denominator to its numerator, we can rewrite it as y of s is equal to upon this numerator to denominator of RHS, that is. By using the property of a plus b whole bracket square, we can reduce this and rewrite it as y of s equal to s square plus 2 into s upon s plus 1 whole bracket square into s plus 1.
Here we cannot apply the inverse Laplace transform directly, so we use partial reduction method. We get and value of y of s is and when this denominator goes to the other side, we get Now put s is equal to minus 1 in equation second, we get minus 3 is equal to 2. So the value of b is equal to minus 3 by 2. And now comparing the coefficient of s raised to 0 in equation 2, we get a plus b plus d is equal to 0.
Further, we have to compare the coefficient of s square. So by comparing the coefficient of s cube from this equation, so we get a plus c is equals to 1. Now comparing the equation of s square, we get a plus b plus 2c plus d is equals to 0. Now we have the value of a plus b plus d. Substitute the value of a plus b plus d into this equation, so we get c is equals to 0. Now substitute the value of c in this equation, so we get a is equals to 1. Now we have the value of b is equals to minus 3 upon 2. So substituting the value of a, b, c in this equation, so we get b is equals to 1 upon 2. Now we have to substitute the value of a, b, c, d in equation first, so we get y of s is equals to 1 upon 2, 1 upon s square plus 1. Now by using inverse Laplace transform, this y of s become y of t. Using inverse Laplace transform of the first shifting, we get e raised to minus t. This minus 3 by 2 is as it is. Now in this equation, first of all we have to take inverse Laplace transform. So we get e raised to minus t into t. So taking inverse Laplace transform of this, we get 1 by 2 into sin.
So further, taking one more example of linear differential equation, we will see this example. So to solve this example, we will take Laplace transformation on both hand side. So using Laplace transformation of derivative, we can write substituting the value of y of 0 and y dash of 0. Next, taking the y of s as common, we can write so by rearranging s of y of s equals to 1 upon s square plus 4. So taking here inverse Laplace transformation, this y of s become y of t, and here this can be written as 1 by 2 sine 2t. This is the required solution for the linear differential equation. So from this video, the learning outcome is that we saw the properties of Laplace transformation, inverse Laplace transformation to solve the linear differential equation. Thank you.